Hello everyone, welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem 3634 minimum removals to balance array. You are given an integer array nums and an integer k. An array is considered balanced if the value of its maximum element is at most k times the minimum element. Okay, so let's take an example of this as an array. Okay, let's say we just have 2 3 4. Okay, and we have been given k is equal to 2. If you see, the minimum element in the given array is 2 and the maximum element, which is 4, which is less than or equal to 2 times k, which is 2. So this is considered as a balance array. Okay, balance array. You may remove any number of elements from nums without making it empty. Okay, let's say we have one more element called 5. Okay, here the maximum element is 5 and the minimum is 2. 2 times 2 is not less 5 is not less than 2 times 2. So I will be deleting this, and now in this case the maximum element 4 is less than or equal to 2 times 2. Now this is balanced. Okay, and the number of elements which we have removed is equal to 1. Okay, return the minimum number of elements to remove so that the remaining array is balanced. Okay, so in the previous example I have deleted 5 to make 2 3 4 as balanced, and the number of deletions is actually 1. Okay, if you notice, the order of 2 does not matter over here, even though the 2 is here. Okay, still I can say 2 3 3 to 4 is balanced, correct? The order of minimum and maximum does not matter to me. Okay, still this is balanced. 4 3 2 is also balanced because the maximum element in this array is less than or equal to the minimum element times 2. So the position of numbers is not at all concern for us. Okay, so what we can do, we can simply sort the array, and the next thing is to minimize the number of elements to remove. Okay, so let's say we have chosen a number, let's say in a given array. Okay, let's assume that this is array and we are looking at this particular subarray. Okay, now if we choose a number which is higher. Okay, let's not go in the direction. Okay, let's say we have this array. Okay, now for a given minimum value, let's say minimum is 2. So for a given minimum value, what is the maximum value? Should be, the maximum value should be less than or equal to 2 times 2, which is 4. Okay, now that I have to identify what is the starting index. Okay, what is the starting number which is greater than max. Okay, what is the first number which is greater than max. Okay, if you see, 5 is the first number which is greater than max. That means 2 from index from 2 to 4, this is a balanced. Okay, because the maximum element is less than or equal to the minimum element times k. So in order to make this entire array balance, okay, in I have to delete this and this for if I choose minimum as 2. Okay, just an example. Okay, so for a given minimum value, in order we will be identifying what is the upper bound of the maximum value, which is the given minimum value times the k. Okay, and then we will try to do this approach for each and every element. Okay, let's assume 2 is the minimum value in the final subarray which we want, and then we will be identifying the what is the upper limit of the max, and we'll assume 3 as the minimum value, and we'll identify what is the upper limit of the max, and upper limit of max is 7. That means from 3 to 6 it is balanced if I remove 1 2 and 7. Okay, so once we identify the upper bound of of a particular element, the this part of it, okay, the just below the index, the length of the subarray would be the index minus the current element, so that would be the length. So I have to do the reverse calculation. Okay, I have to keep this, but I have to remove all other elements. So I will do n minus the length of this particular array. That will tell me the remaining elements which needs to be deleted. Okay, So for a given minimum, so the problem statement boils down to identify the upper bound for max, okay, for the current max which we are choosing for a given minimum, right? So the brute force approach is to do the linear search and identify the first upper bound. The optimal way is to apply the binary search, okay. The reason being the elements are in the sorted order, so we can easily apply the binary search on it, okay. So the upper bound logic will look something like this, okay. We will be instantiating our left and right, okay. So we will be passing the left. If I choose my mean as this, so my search space would be this. So I have to look for a given left, I have to look in this range, okay. So I will be passing the left as the current index plus 1 to our function, and for this range I have to identify the upper bound for given target, okay. So this is pretty straightforward algorithm. So as long as my mid is greater than or equal to target, okay, as long as my mid is greater than or equal to target, that is my mid is a potential answer. So I will be updating my right equal to mid. If that is not the case, that means I will be updating my left equal to mid plus 1. Once this loop will end, okay, I will again check whether my right is actually greater than or equal to target. If yes, then I will be returning right, otherwise I will be returning the n, okay. So this will give me, if all the elements are lesser than the target, that means the upper bound will be, in this case I will be returning n as the upper bound, okay. So let's look at the actual algorithm, okay. As I mentioned, we will be sorting the elements. In the worst case, we will be removing all n minus 1 elements, and I will be ending up with one single element in my array. So in the worst case, the answer will be n minus 1. So that is what I have defined. And for every given I will be considering it as a minimum element for my final balance array, and I will be identifying what will be the upper bound for it, okay. So I have to find the upper bound for the given target, which is nums of I times k, and I will be doing search from the current index plus 1, okay. So my answer will be n minus current index, the end of the uh, whatever the upper bound we got, minus I. So since we are trying to minimize this, I will be taking minimum of answer and the current answer, okay. In the end, my answer will contain the overall minimum number of elements which needs to be removed, okay, in order to make the array as balanced, okay. Now if you see, let's try to analyze the time complexity, okay. This is straightforward binary search where we are shrinking our search space every time by half. So this will be log n, and for every given index I, we are trying to apply the binary search on it, okay. So this will be n log n, okay. Yeah, that is the time complexity. And space complexity is the space coming from our sorting algorithm, and the which will be big of n as well, okay. So that's all about this problem. If you like the video explanation, hit the like button and hit the subscribe button, and also share your valuable feedback in the comment section. Thank you.